Originally founded in 1918 as a foundry producing bearings and other wear components for the then thriving local steel industry, M7 Technologies is now a third-generation, family-owned and operated, heavy industry service company. M7 began to leverage large-scale laser-based metrology in 2004 to deliver competitive advantages to its clientele. The dense dimensional metrology data derived by laser trackers and scanners is being used to improve alignments in large gearboxes, line shafts, table rolls, and other related mechanical transmission equipment. The improved alignments lead to longer equipment life and increased plant throughput for the remaining regional steel industry. An important skill set involving the gathering, handling, processing, summarizing, and reporting on dimensional data sets up to several million measurements was fostered. These rich data sets yield important information previously not available to precisely characterize size, form, location, orientation, and interrelation of heavy industry components and subassemblies. The tools and skill sets fostered at M7 since 2004 provided the foundation for attacking the elusive challenge of high-speed metrological scanning in CNC machining centers. In the fall of 2012, M7 conquered the elusive challenge of registering metrology data with machine tool position while the machine tool is in motion. This new capability allows a statistically rich 30-second setup scan to phase directly into machining well before the current touch probe technology has gathered 10 points. While the previous technology was used to pick up a part's origin, M7 scanning technology picks up the origin and finds the highest points on the rough casting. This scan data is summarized in seconds and is used to adjust the first roughing pass so that it immediately engages the part and begins to remove chips. Today's common practice is to start the roughing of a blank well away from the nominal surface and normally cutting air for a significant period of time before the cutting tool ever removes a chip. After machining is complete and while the part is still fixtured in the machining center, the new scanning capability is being used to fully characterize key features. In the example of the run-out table bearing box shown, 6 planar surfaces and 1 cylindrical feature are fully characterized in just under 2 minutes. Moments later, the metrology report is presented to the machine tool operator on a local PC. This serialized report informs the operator whether the part is good or not, and whether or not rework is required prior to ever breaking setup. This immediate point of production metrology feedback will facilitate statistical process control to its theoretical limit. Part variation, machine drift, tool wear, and serialized data mapped against a part's three-dimensional model will become commonplace throughout American manufacturing. In 1959, the current metrology industry was born with the introduction of the first coordinate measuring machine at the International Machine Tool Exhibition in Paris. A little over a decade later, Renishaw introduced the touch trigger probe to address a specific inspection requirement on the then state-of-the-art, now extinct Concorde aircraft. Later in the 1980s, Renishaw introduced the motorized probe head, which significantly increased the programmability and therefore the productivity of coordinate measuring machines. For the last 50 years, precision metrology has been largely limited to coordinate measuring machines operating within quality control laboratories, not on the shop floor, not in the production environment. Within the last 10 years, a new style of hardened coordinate measuring machines has left the QC lab and entered the production environment. These new machines still require the parts to be removed from the production equipment, but do facilitate a much quicker turnaround between production and inspection. Also within the last decade, new inspection tools have been introduced into the coordinate measuring machine-based technology. These new inspection tools include laser point, laser line, and visual inspection instruments. Touch probe technology has been available for machine tools for decades. Touch probe metrology in machining centers is slow, and therefore most equipment asset owners elect only to use it for picking up a part's origin and verify limited feature size inspection. M7 has conquered the elusive challenge of registering metrology instrument readings with machine tool position without stopping the machine tool. This basic capability will revolutionize the metrology industry by bringing high-speed characterization to the points of production and away from dedicated metrology platforms such as coordinate measuring machines, laser trackers currently in use. In the third quarter of 2013, M7 will evolve its point of production scanning capability to include surface and subsurface characterization and three-dimensional registration of associated data. Modern eddy current and ultrasound instrument readings will be used to locate and characterize surface and subsurface anomalies. This comprehensive metrological capability will increase the characterization data available by orders of magnitude, facilitating life cycle serialized component management, individual component finite element analysis, counterfeit component detection and removal from the marketplace, and many other currently unforeseeable value streams. Thank you for your interest. Our contact information is provided for your convenience.